In this lesson, we'll take a look at a diameter drawn perpendicular to a chord. So here we have circle O, and there's a diameter drawn. And now let's draw a chord in here so that it's perpendicular to this diameter. Alright, so now we have that chord. Let's give some of these letters. We have diameter AB and chord CD. And we'll say it intersects at P. And it's perpendicular at point P. Well, when a diameter and a chord intersect, the diameter bisects the chord. So CP is going to be the same length as PD. Notice that the chord does not necessarily bisect the diameter. This side, AP, is much longer than PB. But the chord is split in half. CP is the same length as PD. That'll happen regardless of where we draw the chord, just as long as it's perpendicular. So here we'd be able to see that these two would also be the same length as each other if it were perpendicular to the diameter. But looking back at our original diagram, we have AB intersecting CD. Okay, not only are these two line segments going to be the same length, but these arcs here are going to be the same length. So arc BD and arc CB are going to be the same length as each other. So we have arc CB is congruent to arc BD. Okay, also these arcs are going to be congruent to each other, so AC and AD. AC is this big arc here, and AD. These are also congruent. So we could write AC is congruent to AD. But very important, you have to have a diameter. You have to have a chord, and it must be, well, they must be perpendicular to each other. And if that's the case, we get two pairs of congruent arcs, and also the diameter bisects the chord.